All right, previously we learned how to read Young's modulus from the stress strain diagram. And Young's modulus is one of the most important information you should able to read from the diagram. And the other information you can read from the diagram includes first is the proportional limits. Let's call that point P. P is a point on the diagram in the linear region, which is the end point of the linear region. And that's a proportional limits. And that tells you the end of elastic deformation. So before this point, we have elastic deformation. In this region, a material will act like a spring. When you apply a force on the material, it deforms, and once you release the force, and the material will return to its original shape or length. It's just like a spring. It stores energy and it will release it, return to its original length. But once you pass that point P, and we're entering this plastic deformation region, or it's called permanent deformation, which means once the stress is larger than P, is larger than, let's call that corresponding stress sigma P. If you keep applying, increasing the load to the material, and that load is larger than sigma P, and the deformation occurs in the material will be permanent, which means if you release the load, and you're gonna have some permanent deformation left in the material. And that's all in between here and here. It's all plastic deformation region. And another concept you can read from this diagram is called yield strength. So this is the starting point of stress strain curve into the plastic region. Usually somewhere around here. Let's call that the corresponding stress is called yielding stress. And sometimes this yielding strength point is hard to determine, and there are a couple ways to deal with that. The first way to deal with that is to use a 0.2% strain offset to find the yield strength. Offset. So this string offset will give you a line that intersect with the curve. So you need to find the intersection of that offset line. And here's example. Let me use different color. First, you need to find where's strain 0.0002 on the diagram on your y-axis. For example, if it is somewhere around there, then you need to draw a parallel line to this straight line. So draw a parallel line, and this green line I'm drawing here, it's the 0.2% offset line. This line would have an intersection with the curve, and that intersection, that's right there, will tell you what is the yield strength. That makes sense. So this is one way to find yield strength. Another way is if a material has it's non-linear elastic. Then we use 0.005 or 0.5% strain offset. To find out what is the yield strength. Or sometimes in the curve we have a upper and lower yielding strength. Under that condition, we just need to take average, find the average yielding strength. Let me give example for that. That's when you have the stress strain curve looks like that. So you're gonna have a high upper yield strength and a lower yield strength. And just need to take an average to find the yield strength. And keep in mind, and yield strength is when the curve, the stress strain curve, start to turn into the plastic region. And this one another important information you